In this video, we're going to be matching graphs with polynomial functions, okay? And we're going to do this without using the calculator. All right, so let's look at f of x here. We have f of x is equal to negative 2 times x minus 3 squared times x squared minus 1, okay? So if we take a look at that one, we can determine a few things from it. First of all, we can determine the end behavior. Okay, so the end behavior is going to be determined by the degree and the sign of the leading coefficient. Okay, so this term is going to be an x squared term because we have an x and it's being squared here. And this is also going to be an x squared term. So you're going to get x to the fourth. Okay, and since the leading term here is negative, you're going to get negative 2x to the fourth. Okay, so what this means is that the end behavior is going to basically look like this. Okay, and that's because it has a negative coefficient and it has an even power for the end behavior. Okay. Another thing that we can say out of this is that we have, looks like we have four x-intercepts. Well, actually, we only have 3 because this one's going to have degree 2. So we have x minus 3 equals 0. That's x equals 3. And that one, since it's got a square on it, okay, so it happens twice. This means this is going to bounce off the x-axis. Okay, because it's got an even power. Okay, now with the x squared minus 1 equals 0, that actually can factor into x plus 1, x minus 1, or you can solve it using the square root property. Okay, but this is going to give you two different solutions, x equals negative 1 and positive 1. And since they have, both of these have degree 1, they don't have any exponents out here like this one did. Okay, so these are going to cross the x-axis. Okay, you can also look at the y-intercept. So if we plug in f of 0, we would get negative 2 times 0 minus 3 squared times 0 squared minus 1. Okay, so that's negative 2 times negative 3 squared times negative 1. Okay, so the square on this one makes that a positive 9, so it's negative 2 times 9 times negative 1, which will give you positive 18. So we cross the x-axis, or the y-axis, at 18. That's your y-intercept. Okay, so we got our x-intercepts, we got our end behavior, we know if it bounces or if it crosses. Okay, so we take a look and we find one. Okay, we need to find one that's going downward both sides, so that this one is going down on both sides, and this one is going down on both sides. Okay, we also need to bounce off the x-axis at 3. Okay, so this one looks like it bounces off the x-axis at 3, and this one also looks like it bounces off the x-axis at 3. And we need to cross the x-axis at negative 1 and 1. This one doesn't cross the x-axis ever, but this one does cross right here and right here. Okay, so this is f of x. Okay, let's take a look at the other one. We have over here g of x is equal to 2x cubed plus 6x squared. Okay, if we factor out an x squared, that would leave us with 2x plus 6. We could also factor out a 2, so 2x squared would give us x plus 3. Okay, so that gives us two solutions, x equals 0 for this one, and x equals negative 3. This one would bounce, and this one will cross. Okay, this one is bouncing because it has degree 2. This one is crossing because there's no exponent, so it's degree 1. All right, so odd degree cross, even degree bounce. All right, y-intercept, you'd have to plug in 0. That's going to turn out to be 0 because both of these terms have an x in them, and if you put a 0 in for x, the whole thing goes to 0. So your y-intercept is y equals 0. Okay, and we can also look at the end behavior. So this is an odd, the leading term here, the highest degree term is x to the 3. So that's odd, and this is positive, so it's going to look like this. Okay, so we need to find one that's going down to the left and up to the right. Okay, so this one's going down to the left and up to the right. This one is going down to the left and up to the right. and that's it. So it's one of these two. We also need to bounce off the x-axis at 0 and cross at -3. This one crosses at -3 and bounces at 0. This one bounces at -3 and crosses at 0. Okay, so we want the bouncing one to be the 0. So this is g of x. Okay, let's do a couple more of these. Okay, so we have f of x is equal to negative times x minus 4 cubed times x minus 1. Okay, so this has degree 3, so that's an odd degree, and this has degree 1, which is an odd degree. Okay, so when I set x minus 4 equal to 0 and x minus 1 equal to 0 to find the x-intercepts, they're both going to cross the x-axis because they both have an odd degree exponent. Okay, so this is x equals 4 and x equals 1. Okay, so both of these cross x-axis. Okay, the y-intercept we plug in as 0, so f of 0 is equal to negative times 0 minus 4 cubed times 0 minus 1. Okay, so negative, and then negative 4 cubed is negative 64 times negative 1. Okay, so we have negative, negative, negative. So our answer is 64. So we're going to cross the y-axis at 64. Now, probably on the last problem, this wasn't very useful, but it might be useful sometimes to us. Okay, in behavior, so this is going to be an x cubed term and then an x term. So that's an x to the 4 term for our leading term. So this x cubed and this x get multiplied to get x to the 4th. The negatives out front. So our leading term is negative x to the 4th, which means it's even power and it's negative. So the in behavior is going to look like this. So we're going to start from the left. We're going to cross at 1, and then we're going to cross again at 4. Okay, so let's see if we can find one that looks like that. Okay, so this one looks like the correct in behavior, and this one looks like the correct in behavior. Okay, so it's going up and then back down. So it's one of these two. Okay, so which one of these crosses at both x equals 1 and x equals 4? Looks like this one does. These bounce at x equals 1 and 4, so this is wrong. So this is f of x. Okay, now let's do g of x, or h of x rather. H of x is equal to 2x cubed minus 4x squared minus 6x. Okay, so first let's factor out an x out of this, or let's factor out a 2x out of this. So that becomes x squared minus 2x minus 3. Okay, and this can be factored. Two numbers that multiply to get 3 but add to get -2. That's -3 and 1. So this factors into 2x times x minus 3 and x plus 1. Okay, 3 solutions here, all with degree 1. This has a degree 1, this has degree 1, and this has degree 1. So all 3 of these are going to cross. So we get 2x equals 0. That gives you x equals 0. X minus 3 equals 0 gives you x equals 3. And x plus 1 equals 0 gives you x equals -1. All of these are going to cross. They're all going to cross the x-axis. Okay. We also know our leading degree is odd and positive. Okay, so that means it's going to look like this. Okay, and the y-intercept, if we plugged in zeros to all these, our y-intercept is y equals 0. Plug in 0, 0, 0, they all go away. All right, so let's look for one that looks like this. Okay, so we've got which ones? Oh, here we go. So this one looks the correct way, and this one looks the correct way. So it's either B or F based on the in behavior. And we know we need to cross at 0, or at -1, 0, and 3. Cross all 3 times. Okay, so -1, 0, 3. All 3 cross. -1 bounces and then 3 crosses, so that's not the right one. So this is h of x. Okay, it has the right end behavior and it crosses in all 3 of the right spots. And it even has the y-intercept in the correct place right here. And that's it.